sorry, somehow they got cut off. But I think you know how if you use tangent to get this angle right here, using tangent opposite over adjacent would help you get that. Okay. All right. The other one. All right. So what I did, I think I was talking to you about, and I'm sorry about the quality of this video, but I drew the diagram out, which I think you knew. Okay. The most important thing on all of these is realizing that your horizontal velocities and distances are totally different from your vertical. So always think of them as being different. So like right here, that's why I labeled 65 miles per hour. That's my initial X velocity. That's why I put that X in there. Okay, so always think in terms of X and Y. X and Y. Okay, and then my X distance is 90 feet. Okay, that's 90 feet. So they're asking how far would that thing drop if it went 90 feet. Okay. All right. So for this one, our given, I wrote that out. We always know G. I just like to write it in. And something else too. I don't know. Again, I'm trying to give you any kind of tips that will help you. I know we always know this, but it just makes me feel better when I know I've got a bunch of knowns. So I like to throw stuff in there even I don't really know. Another one that we could throw in is your, I know this wasn't in the problem, but you know your VY, your initial Y velocity is 0 also. Okay. All right, so I put this in here. Again, I apologize for the video. The secret to this type of problem is find the two equations that can take you from what you know to what you don't know. All right. So, and I know that sounds strange, but there's not really there's not really one equation that's going to get you to the answer on this one. So what I'm going to do, what I did was I used this equation right here because I know X, I know initial velocity in the X direction, and I know my X, my initial X. We're going to treat that as 0. Okay. All right. So I plugged in 90 feet. My initial X is 0. And then we got 29.1 meters per second. Now where I got that from is I took 65 miles per hour and I changed it into meters per second. I did a conversion there, and I can show you how I did that. But I think I was telling you that last night. Try to get stuff in meters per second because your units always have to match up. That's important in physics. All right, I solved for T. Okay, I kind of got everything by itself, but I solved for T. So you end up with 27 point, and this, again, I changed 90 feet to 27.45 meters. So divide by this, okay, and I came out with my time is 0.94 seconds. So I'm going to go back up here. 0.94 seconds is how long that thing was in the air. Okay, that's how long that thing was in the air. All right, so once you find out how long it's in the air, now you can use your Y equation that has, because basically we're trying to find Y. That's what we said right here. We're trying to find Y. So Y, I know Y sub naught. Okay, and that's another one I should have wrote down because it's my Y sub naught is 0. Because a lot of times these things are 0. My Vy of sub naught is 0. Okay, and then I just calculated my time, which is 0.94 seconds, and I know G, and there's my time again. So I put it in that equation, and I ended up with 4.31 meters. So what that means is the distance that that thing is going to drop. I can't remember in this one whether they were throwing something. They might have been throwing. Yeah. I think somebody was throwing a ball. in 0.94 seconds, which is almost a second, that thing's going to drop 4.31 meters. Okay, and that's why when you draw your diagrams, try to draw them out as to what's happening. Okay, in the third one, I believe, I remember this, it was yesterday evening when I did this, but a guy was firing a bullet from over here. Now, over the span of, and it said it traveled 1 kilometer to the target. Okay, so there's my target. All right, so when you're trying to fire a bullet, it's going to drop over a certain distance, especially over 1 kilometer. They want to know, all right, and it tells you that it dropped 50 centimeters. So my drop was 50 centimeters. Okay, so let's write down what we know. We know that my X is 1 kilometer. We know that my Y is 50 centimeters. We know that my initial Y velocity was 0. G, of course, is negative 9.8 meters per second. Okay, so that we're trying to find T in this case. All right, now this one turns out to be a little bit easier than the last one because you only need one equation, and this is where projectile motion will get you. And not so much get you, but where you can make your life easier. All right, and I'll tell you this today again, and I know this is going to be kind of hard to explain on this video, but when he fires this bullet, okay, over the span of that time, it's going to drop 50 centimeters. Even if he were standing right here, yeah, it's a horrible drawing, but and drop it in that same time, it's going to drop the same distance. Okay, I think they may have told you that in your notes. Your teacher probably told you that, but it's going to drop the same distance. So all we have to do in this case is, since I know, and there's an equation that has y in it, there's an equation that has y, your initial y position, initial y velocity, which we know. We know what g is. We're just trying to find time. Okay? All right, so in this one, what I did was I changed over my centimeters to meters. Remember, try to get everything in meters and seconds. That makes your life easier. 0.5 meters, that's how many meters 50 centimeters is. Z, my initial y position is 0. Okay, my initial y velocity is 0. Okay, and then T is what we're trying to find, minus 1/2 gt squared. Okay, I can start substituting them from zeros. Now, 0 times anything is going to zero this out. I can go ahead and simplify this part, and that's why I'm getting 4.9 meters per second squared times t squared. 0.5 meters. Okay, I'm simplifying, so when I do the square root, I end up getting the square root of 0.1, which is 0.32 seconds. So what that means is, I know this is crazy to think of, when you fire that bullet, when this guy fires that bullet and it travels 1 kilometer, it's only going to be in the air for like 0.3 seconds, a third of a second, okay, before it hits that target, and it drops that far, okay?